Hey class, Absolute 5 here. So today we're going to talk about implicit differentiation. Now, what on earth is implicit differentiation? So implicit differentiation is where you have two equations and you have two different variables. And the thing is, we would normally take the derivative with respect to whichever variable we choose to do it with, but the second variable we have to differentiate it, but using the chain rule by differentiating it with respect to x, but at the same time we have to differentiate it with respect to y, meaning that like you differentiate whatever, specifically I say y, but you could use any other letter. Well, what I'm talking about doesn't make sense. Let me just show you exactly what I'm talking about. So let's get right into it. Let's get into it. All right. So implicit. So the idea of implicit is that this method consists of differentiating both sides of the equation with respect, put some respect to x, and then solving the resulting equation for y. So our question is going to be, it's going to be a two-parter. Question A and question B. If x squared plus y squared equals 25, find dy dx. Now this looks like a y. There you go. And part B says, find an equation of the tangent to the circle x squared plus y squared equals 25 at the point 3, 4. Okay, so we're going to get an idea of what this looks like right now, because remember, you're taking the derivative of a function with respect to y. Well, y with respect to x. I'll explain what that means when we actually do this right now. So our equation is going to be x squared plus y squared equals 25. So let's try to do the first part of the equation. So let's see, x squared plus y squared equals 25, right? First thing you're going to do is you're going to take the derivative on both sides. So dx of x squared plus dx for y squared equals dx for 25, right? When you differentiate everything, right? Derivative of x squared is 2x plus. Now, when you take the derivative with respect to y, you have to do this. dy dx of y squared becomes 2y times y prime, or 2y times dy dx. So that's your result. dy dx is y prime. It's another way to substitute what we're trying to find. So, but for argument's sake and neatness purposes, I'm going to use y prime. Excuse me. So it's 2y times y prime. Why are we using this? Because look, it's a chain rule. Because this chain rule is this: you're doing the outer function. That's the power. That's the power is 2y. That's with respect to x. But then you got to find the derivative with y, with respect to y, which is y prime. That's why that's why this is a chain rule, so it's being multiplied here. So then the derivative of a constant we know is 0. Because constant functions, their slopes are always 0. Okay. Now I'm going to solve for y prime. Take away 2x on both sides. I'm left with 2y times y prime equals negative 2x. I divide both sides by 2y. The 2's cancels, so I'm left with y prime equals negative x over y, right? And then the second part of the equation, remember, we're not finished yet. It says find an equation of the tangent to the circle, or tangent line to the circle, right, of x squared plus y squared at the point 3, 4. So if you remember, to find things that are tangent, you're finding the slope. So you find a line you find an equation that's hitting the slope of the line, of the circle here, meaning, you know, the formula for slope is m. So you're going to plug in 3, 4 here. So this becomes y prime equals negative 3 over 4 because of the negative sign. Because when you plug it in, that's what's going to happen. You get negative 3 over 4. So this is your slope. This is your m. This is your slope. So now, I'm going to erase the top because we're still not finished yet for this part of the equation. Let's say we want to find the tangent line, which I was supposed to put line, but that's fine. Does anyone remember the formula for this? It's y minus y1 equals mx minus x1. So we put the points here. So we have y minus 4 equals m is negative 3 over 4, which is what we have here, times x minus 4. So in the end, no, sorry, not 4, 3, excuse me. It's 3, the point is 3, not negative 3. Okay, so we're almost done. Y minus 4 equals negative 3 over 4x. I'm distributing this over. Negative times positive is going to be negative, but negative times negative is positive, and then we times this is 9 over 4. After you do some quick addition here, you get y equals negative 3 over 4x plus 9 over 4 plus 4 over 1. Do the LCD, which is 4. And then you're left with y equals negative 3 over 4x. So this is what? 4, 9 plus, what is that? 16? 25 over 4, and that's your equation of a line that will hit the circle at the tangent. So that's the lesson for you guys today about implicit differentiation. I hope this made sense. Hope you enjoyed it. As usual, be sure to hit that like button, subscribe, share, and subscribe to this channel. Smash that bell button, the bell button, so if you want more content to know about more math, I'm always here for you guys. And also remember that I'm always listening to feedback and suggestions if anything you have. Be sure to leave it down in the comments below. So this has been Absolute 5. I'm Roger Palomino, and math is infinite because there are infinitely many possibilities. Take care.